Okay, so welcome to my talk. So I do a lot of work on basically layer 2 stuff for Bitcoin. And I would say, like in Bitcoin, it's very difficult to make changes, right? If you need a soft fork for something, it's a lot of work, it's a lot of effort. And that's just sort of, I think, what comes with the package of wanting to do something with a system that's inherently decentralized. So Spacechains is one of these sort of layer 2 solutions that I've come up with that sort of tries to fit in between that difficulty of not being able to change Bitcoin, but still wanting to do more. So it's a system essentially to achieve sidechains, but these are specifically one-way pegged sidechains, and we'll get into what that means. So really, the key thing here that I'm trying to achieve with my Spacechains protocol is to get permissionless blockchains that benefit Bitcoin. So it allows you to create more blockchains, but these blockchains are specific to Bitcoin. They are not altcoins. And that is the main important distinction here. Because that is ultimately, I think, a big problem in this ecosystem. Whenever you want to innovate and you want to do something new, and you can't immediately do it in Bitcoin, you tend to end up with an altcoin. And in my opinion, at least, there are lots of problems with altcoins. And I think it ultimately comes down to this destructive cycle of greed, where basically you have the people that start it and you have the insiders. They have inside information. They know when the token is going to hit the exchange, and then inevitably it's going to pump. And they can insider trade. They can speculate on it ahead of time, and they will always win out. And that goes at the cost of everybody else who's participating. Then you've got early adopters that, if they're lucky, they gain the most. Obviously, some altcoins fail completely. That's possible too. And it's all about marketing, right? It's not about creating a project that is ultimately useful, but it's about creating a project, for altcoins at least, that looks like it's going to be useful in the future, and therefore people are going to buy it now. And that makes the value go up, and that makes everybody, at least who are currently holding the token, happy. And ultimately, and I think this is really sort of a key problem, and this is not a problem that has an easy solution, but there's no incentive to stick around. If you think about let's say you create a successful altcoin, and it goes up in value, and great, you made a lot of money, you were the first person who created it, you gave yourself a lot of tokens. Now you have this new idea. And so you have two options. You can say, like, okay, well, let's try and change the current thing, or let's do another altcoin. And I think that's what we see in the space. And you have a lot of serial altcoin entrepreneurs, whatever you want to call them. But I think ultimately that is sort of the cycle that I would like to see broken, right? Where we can actually stick with one token, in this case Bitcoin, and do everything there as opposed to trying to repeat this cycle over and over again. And yeah, obviously, I think ultimately a lot of these tokens, they just go nowhere. And then the last ones who are holding the bag, they lose out on their money. And ultimately, I think this is sort of, when you do a trade, normally it's a win-win situation, right? Both people are better off. You wanted that new phone, and Apple wanted to get richer, and you're both happy. But in this case, you're sort of buying a lemon, right? You're buying something that you think is going to be great in the future because people told you it was going to be great in the future. And then that might not be the case. So I won't say that there isn't any positive here, right? I definitely think we have basically a lot of innovation that is happening in the altcoin space because there's so much money involved and it attracts so many people. But in my opinion, the positive doesn't really outweigh the bad. It's nice that we get like a lot of zero knowledge proof work and things like that. And I think that is absolutely great. But it's sort of like stealing money and then donating it to charity. Like, that's how I see it, where it's like, sure, you're doing good with the money, but the method also matters. So basically, so it's not an altcoin, but it's also not a two-way peg. And so I think we should sort of start with acknowledging what kind of two-way peg methods there are and why it might be useful to actually do a one-way peg as well. So generally, I would say the most two-way pegs that are out there, they all have a certain limitation or problem or issue that I think fundamentally makes it a trade-off, right? And I think anything with trade-offs, especially on layer 2, it all has a right to exist. I would say I would like to see all of these to come to fruition and have all of it and have everybody just experiment and see what wins out. But I think as long as the trade-offs are different, I think it deserves to be explored and it needs to be built. So what are some of these two-way pegs? I think the simplest one and the one most people know, I think, are federations. So Liquid is a famous example of this. I have another layer 2 design called Statechains, which also makes use of federations, which is a little bit more secure than Liquid, but has other trade-offs. And with federations, ultimately what you're doing is you're giving money to a group of people, and you're hoping at the end of the day that they're going to give it back to you. So you give them money, you put it into a multisig, they credit you a token on their chain, the chain that they control, and ultimately, you hope at the end of the day when you get out that they give you your money back. And so really it's just a form of custody, but it's a better form of custody than what we have today because you're not just depending on one party, you're depending on multiple parties. So I think it's very interesting. But it moves away from this decentralization, what we want in Bitcoin. So then there's drive chains, which is an interesting concept as well. And basically with drive chains, what you're doing is you're trying to give miners your coins. And it's basically the same thing as a federation, but now the miners control your coins. And the only way they can give you, when you do a peg out, when you try to get your coins out, basically there's this process where they have to very slowly and visibly say, okay, look, I'm going to give my coins to this person, and then that happens half a year from now or so. And because that process is slow, deliberate, and visible, the hope is that therefore miners won't cheat. I think maybe depending on sort of how much value is on that chain, that could work out. But if there's too much value, I suspect that is sort of fragile, and it certainly seems more fragile to me than how Bitcoin works today. So if we had the system, I'm personally worried that that's not good enough. But I would like to see the experiment. I think it's interesting. So then there are rollups. So this is sort of a complex topic, so I won't be able to go into it in detail, but I do have an article about it. And basically my high-level claim there is, so the sort of the traditional ZK rollups as we see them in Ethereum, they aren't actually off-chain. So what you do is you actually put them onto the Bitcoin blockchain or onto the main chain. In the case of Ethereum, it's the Ethereum blockchain. And basically you can compress data to some extent, but still the bulk of it is still there. It takes care of computation, it lowers the computation, and that's a really big problem in Ethereum, but it's not really a problem in Bitcoin. And so if you were to sort of put this system in Bitcoin, you end up with maybe a 2x block size increase, roughly, like in terms of transaction throughput. So that's not really that much. And for that reason, I think if it wasn't for the complexity, it's a complex system with novel cryptography, which might not be as secure as what we have in Bitcoin today. I think it's a very tough sell for Bitcoin, but maybe we'll get there eventually one day. So then there are collateralized pegs, which basically you see a lot in the altcoin world, where they try to take Bitcoin and they try to put it onto their altcoin chain, and the way they do it is by using their altcoin as collateral. And I think the big problem with this is basically that it requires the altcoins to have value in the first place, because you can't use something as collateral if it doesn't have value. And considering, my personal opinion at least, is that most of these altcoins will go to zero, I think ultimately that doesn't really work. And even if it does work, it only works up to the market cap of that altcoin. And you need something like 2x liquidity, right? You need a 2x collateral, and that is also, another limitation where you can't really put a lot of Bitcoins on that kind of chain. And very generally, we've seen this with Luna, for instance, which spectacularly blew up recently. But there's this sort of implication that says, okay, we're going to create this other token, and in this case it was a US dollar, UST, and we have our altcoin, and the altcoin is going to be used as collateral. And because people want the UST, the altcoin will have value. And I think that's sort of like the circular reference that just doesn't really add up, right? Where is the actual value in the token? You need to have the altcoin have value first, and only then can you use it as collateral. You can't say, because we're going to use this altcoin as collateral, therefore it has value. And okay, yeah. So there's another one which is called Softchains, which is another one of my layer 2 ideas. And that actually is, yeah, it's sort of interesting. I can't really go into it now, and haven't really given a presentation on it yet. Maybe next year we'll see where I'm at then. But basically, it sort of requires some pretty invasive changes to Bitcoin. So I think this might be an interesting model for an altcoin or at least some other chain. But it's not really something that we can get into Bitcoin, I think, anytime soon. And yeah, so the general gist of the issue here is that a bunch of these just require elaborate soft forks that we're not going to see come to Bitcoin anytime soon. So that brings me to what we're talking about today, that's Spacechains. So Spacechains, despite not being a two-way peg, all the fees of these Spacechains go to Bitcoin miners, and all the value goes to Bitcoin holders. And I think that's ultimately sort of what you want out of a sidechain, out of a secondary chain that is not trying to compete with Bitcoin, that is trying to add value to the Bitcoin ecosystem. So when I say fees go to miners, what do I mean? Well, basically, what you can do with these space chains is you can simulate Bitcoin mining, or you can simulate mining inside of Bitcoin. So somebody can create a secondary chain, and instead of having its own proof of work, we actually do it inside of the Bitcoin blockchain. And we just use Bitcoins. And the way we do that is basically to somehow, and I'll get into details later at the end of my presentation, somehow we create one freely spendable output per block. And so this output can be spent by anyone, and that's sort of the key. And then basically everybody tries to spend it. So I can try to spend it, you can try to spend it. But what Bitcoin miners do is they take the transaction with the highest fee. So through something called RBF, which is in Bitcoin today, it's replaced by fee, we can try to outbid each other. And the miner will just take the transaction that has the highest fee, and we'll add that one to the block. And so what we do is whoever wins this bidding war basically puts their hash of the space chain inside of the transaction that they used to bid. And so the winner basically is the person who wanted to create the space chain block the most, was willing to pay the most to miners, and in return they get the fees that are on the space chain. So yeah, the highest bidder gets the space chain fees, and the Bitcoin miners get the Bitcoin fees. And sort of what's important to note here is that what's nice about this system is that it really just completely leaves Bitcoin miners out of it. The whole process is just regular Bitcoin transactions, and by people just creating these transactions and miners just doing what they're already doing, which is picking the highest fee transactions, we get consensus on the secondary chain. So to give you sort of a brief visual overview of what this might look like, let's say you have a Bitcoin block, and you have, inside of this block, you have a transaction with a space chain hash. And this was this bidding, and so one of the transactions got chosen, and that transaction entered into the Bitcoin blockchain. And so there's a hash, and so as soon as it hits the Bitcoin blockchain, the person who chose that hash will reveal their space chain block to the space chain network. And this moves forward, so the next Bitcoin block comes in with the same process. But then, you should note it's possible to do a fork, right? Just like in Bitcoin, here you can fork as well. So the space chain blocks also choose which space chain block they built on. And so in this example, we went from block 1 to 2, and then suddenly there's another block 2. So there's 2A and there's 2B. And so now there's a fork. And the reason that needs to be possible is because 2A could just be a nonsense block with no actually valid data. And so we need a way to sort of work around that. Or even worse, the block is valid, but it's being withheld, so nobody actually has it. So you need this kind of forking mechanism. And the way it works is basically because we're sort of tied to Bitcoin's one space chain block per Bitcoin block. We don't really need to check like it works in Bitcoin. If blocks come in faster, we adjust the difficulty. Now the difficulty actually sort of follows Bitcoin. And so you can just count. You can just say, okay, well, which chain is longer? And that chain is going to be the valid chain. So basically, as soon as another block appears, the fork sort of resolves. And now we all know we're following block 3B. Especially if consensus moves forward, it becomes even more clear. So we've explained how you can create another blockchain. But what we haven't really discussed is how to get rid of the altcoin, right? How do you have a chain now, and the chain exists inside of Bitcoin, and all the fees go to Bitcoin miners. Okay, great. But now I want to use this chain. Now I want to make a transaction. So what we do is we burn Bitcoins. So we allow people to destroy their Bitcoins in order to create a space coin. And this is basically the mechanism where you tie the value of the tokens on the secondary chain, on the space chain, you tie it directly to Bitcoin via a one-way peg. So these space coins, what do they look like? So one Bitcoin gets you one space coin. The value of these burned Bitcoins, which is important to realize, actually goes to Bitcoin holders, because what you're doing is you're destroying Bitcoins. You're lowering the amount of Bitcoins that are in existence. And because of that, basically you make Bitcoin more scarce, and all the remaining people, their Bitcoins go up in value. So what's interesting to note here is that Bitcoin, by definition, is more valuable than a space coin. And that is really important, right? That is what makes it not an altcoin. If you want to speculate, then the best thing you can do is just hold Bitcoin, because people, if the space chain is popular and more people burn their space coins, it's Bitcoin that goes up in value. It's not the space coins that go up in value. And so what's interesting here is that basically what this means is that space coins, they only have non-speculative value. You can't go and hold it and hope for these space coins to go up, because they're never going to go past one Bitcoin. One space coin will never be worth more than one Bitcoin. And with that, we really sort of incentivize people to only want these coins, only want these space coins if they actually want to do something. They want to access functionality on the space chain. So there's no longer this incentive to say like, okay, well, I think this space chain is going to be popular in the future, therefore I want space coins now. No, that doesn't matter. If you think it's going to be more popular in the future, you want Bitcoins, because that's where all the value goes. And I think that gets rid of a lot of this speculation, basically. So really, the second question to ask here, I would say, is, okay, well, what kind of functionality can you access? Why would somebody want to use a space chain today? So let's get into that and discuss some examples. I think ultimately you could say it's basically anything an altcoin can do can now be done as a space chain, can now be done in a way that helps Bitcoin. But to give some examples, I think asset issuance is a perfect one, where you can basically do stablecoins, you can do NFTs, you can do a federated two-way peg. So this is not trustless, but if somebody wants to issue a two-way peg via a federation, via multisig, that's perfectly possible. And the chain itself will still be, fully trustless and decentralized, just that token might not be. You can do decentralized DNS. So we have an example of this, which is Namecoin. But Namecoin, you have the problem of the speculative token, right? And I think ultimately, if you want to do something like decentralized DNS, you don't really care about the token. It's not that you want to buy into this new token, but you sort of have to. And this sort of takes the token out of the equation. Or at least it replaces it with space coins, which are non-speculative tokens. You can do BIP47 payment code registration. So this is something I'm not going to go into. At 3 p.m., I'm giving a mini workshop. It's going to be a small room, I think just 15 people. But if you know something about elliptic curve cryptography, you can maybe watch that presentation or come by, and we'll talk about something called silent payments, which is sort of related to payment codes. So I won't go into this now. And so there's another interesting use case, which is low value on-chain payments. And so this sort of depends on how much value there's actually going to be inside of, in these space coins. But if these tokens hold some amount of value, which I think they won't hold a lot of value, because nobody's gonna hold thousands of dollars worth of space coins, I don't think. But maybe for a couple of $100, maybe you'd be okay. And then you could create a space chain that's maybe a big block space chain that you could use for simple payments. And that could be an interesting experiment to run. And basically, yeah, you can really do anything that requires a global consensus. So that's really sort of the nice thing here, that you can create any chain you want and you can sort of get consensus as long as there's a network of users, which obviously is a prerequisite. So yeah, what's also interesting to note here is that basically a single hash on the Bitcoin blockchain, a single transaction, can support any number of chains, because this is actually you can have a space chain inside of a space chain. So as soon as you have your first space chain and all the other space chains exist inside of that space chain, you basically have just a single transaction per Bitcoin block supporting an unlimited number of chains. So it's really scalable in that sense, where it doesn't really put a lot of friction on the Bitcoin blockchain, while simultaneously you still have this sort of the fees going to Bitcoin miners. So that's really nice. And yeah, so it's entirely permissionless. Anyone can create their own chains. And that's sort of my hope for this, that we get this ecosystem that's maybe a little bit similar to Lightning, where people start creating their own chains, and some of them take off, some of them don't take off, but we get some of this permissionless innovation that we see in altcoins today, but we have a hard time sort of getting into Bitcoin. So let's talk a little bit about the sort of the price, like what's going to happen to these space coins, what's going to happen to their price. I alluded to this a little bit already, but I think it's sort of it's an interesting thing to think about, and I think it's difficult to wrap your head around. So I think it's good to kind of go through it. So I think ultimately the first thing to note here is that the value of the token, the value of these space coins, depends on the current demand of block space. As long as people are constantly wanting to use the block space at a certain rate, the token is going to be pretty stable in value. If demand for block space goes up, that's fine too. You just hit the ceiling. People are going to burn more Bitcoins to create more space coins. But the moment it goes wrong is when demand goes down. At least it's never going to be overvalued, right? Like what I mentioned earlier is that you're never going to speculate on buying a ton of space coins to hope that they're going to be worth more than one Bitcoin, because they can't. And the theory is that because there's no pump, right, nobody's buying into that expectation unreasonably, there's not going to be a dump. So that hopefully makes it more stable already. And then, yeah, so it's unattractive for storing value, right? Like really, if you want to store your value, you're just going to hold Bitcoins. And the nice thing is that even if it goes down in price, it doesn't really matter, because ultimately what you want to do is you just want to have these tokens to pay for fees. And so maybe you're going to have $20 worth of space coins, and you're going to use them to send your favorite NFT to your friend or something. And that's going to be that. And if those $20 go down in value, now it's $10, sure, that's not ideal, but it's not the end of the world either, because you're not storing your value there. So my theory, at least, is that either it's going to be close to the value of Bitcoin, where people basically think that it's going to be, there's going to be more demand for the block space in the future. Therefore, everybody sort of accepts that it's going to be worth one Bitcoin today. Or maybe slowly it will taper down, where the value goes below that of one Bitcoin, but it just kind of slowly goes down. And I think that either way, I think that's perfectly acceptable. I think the worst case scenario you can think of is where you have a space chain, it's popular today, but then a new space chain comes into existence, which people like more, and everybody abandons the first one. Then whoever holds those tokens will eventually lose their value. But the assumption is that nobody's ever going to hold a lot of them. So even in that case, it's not a bad thing. So I think this is kind of my, I don't know, favorites. I love it and hate it, basically. So a lot of people, they come to me and they say, well, Ruben, you're asking me to burn my Bitcoins. That really hurts. Burning feels bad. And, I understand that. The first thing I will say is I don't think it's bad at all. Like ultimately, it's just part of the system. And if you want to destroy your Bitcoins, it's good for anyone else who doesn't destroy their Bitcoins. And it's good to note here as well that you don't have to destroy your Bitcoins. You can just buy these space coins off the market. And then somebody else will basically have burned their Bitcoins and you buy it from them. But instead of trying to argue against this, instead of trying to say like, look, it's really fine, I'm just going to present an alternative here. And so what you can do is you can pay Bitcoin to future miners. So instead of burning, let's say, one Bitcoin to create one space coin, you can lock up one Bitcoin for 2 years, let's say, and it needs to be a long time period because miners sort of need to expect that they're going to be able to get it in the future. And then 2 years from now, the output gets unlocked and it can be taken by anyone. And when it can be taken by anyone, what that means really is that miners are going to take it. Right? Because miners ultimately decide what goes into a block, so they will take that fee. So by paying out the Bitcoins to future miners, basically you remove it from the system temporarily, and eventually it becomes available for miners. And then miners will compete to try to get it. And what that means is that instead of destroying the Bitcoin, you're basically turning your Bitcoin into proof of work. So the miners, like, I guess it's still destruction of value, but in this case, it's destruction of electricity, right? By generating more proof of work. So what you're trading off here is that instead of Bitcoin going up in value, the more space coins enter the system, the security of Bitcoin goes up. And so that's an interesting trade-off. And one of the things you can do there is maybe smooth out the future subsidy, where today you have the halving, which is very extreme, and eventually we run out of subsidy entirely. So maybe you can use this sort of, so instead of sort of deciding, okay, well, it's going to be every 2 years, or 2 years from now the miners are going to get it, you sort of try to smooth it out, or you try to extend the period that miners get fees to increase Bitcoin security. And so I think ultimately it's sort of a question of whether you want to do this or you want to just burn Bitcoins. I think it sort of depends on what is going to happen with Bitcoin in the future. If we don't have enough fees, if Bitcoin security is in danger or people think it's in danger, then it's preferable to do this. If people don't think that's the case, then it's preferable to increase Bitcoin's value by burning Bitcoins. Okay, so to give a bit of an example here, a potential future could be we have the Bitcoin blockchain, then we have one space chain, that's sort of the main space chain that is maybe a conservative space chain that's very similar to Bitcoin, and everybody else connects their more crazy space chains to that. So maybe we have this big block space chain that we use to pay for small fees to people, sort of like Lightning-ish, and maybe we have another space chain that focuses on assets, but it's confidential assets, so there's a lot of privacy there as well. Maybe you have a space chain that focuses completely on a dollar stablecoin, like USD Tether or something else, and basically you don't even have space coins on there. It's just purely this alternate chain with issued dollars that people use just for holding dollars, basically, and trading from Bitcoin to dollars. And then maybe we have some experimental technology like my Softchains proposal, which sort of allows you to have this sort of sidechain system. And maybe you have a DNS chain or like a group of DNS chains that are sort of tied together. And what's interesting there is you sort of have a hierarchy, because if you want to validate, like what you always have to validate the parent. So if you, let's say, connect to DNS chain 3, you also have to connect to chain 2, chain 1, the space chain, like the main one, and the Bitcoin blockchain. So you can sort of get a tier of like more preferable to least preferable DNS space, basically. Okay, so that brings us to sort of a couple of examples of like interesting things you can do with space chains. And one of the things that is sort of interesting to think about is that you can stabilize the value of the peg, right? Where it's $1 Bitcoin to one space coin. And you can do that by having a consensus rule where you have to burn, everyone who creates a block has to burn a certain percentage of the supply. And it needs to be like a very low amount, so 0.01% or something. You target something like 10% per year or whatever you want to do. This obviously needs to be carefully chosen because it's a variable that's very important, but once set is hard to change. But when you do that, you basically create a way for space coins to exit the system. And so it puts sort of upward pressure on the price. And so with that, you can have sort of a better guarantee, well, it's not a guarantee, a better chance of maintaining that value where one space coin is worth 1 Bitcoin. And if you get to that, it's really cool because then you actually have sort of a two-way peg. That's not quite a two-way peg, obviously, but gets close to it. So the important thing to note here is that the peg is only stable if the amount of space coins that exit the system outpaces the drop in demand, right? If demand drops so far that it just goes beyond whatever is being burned, then you're out of luck. And so maybe this will improve the low value payment use case. So maybe this is good for the big block space chain. But important to note here is that whenever you're burning fees, because that's essentially what you're doing, right? When you force miners to burn a percentage of the supply, it is taken out of their profit. And their profit is there to create proof of work, essentially. And so when you burn a percentage of these coins, you're lowering the security of the chain. So that is a trade-off. And so whether or not that's good enough depends sort of on the security of the chain. So then there's another interesting idea here. And I think, like something that's maybe good to note here is the nice thing about these things is that even if some of these ideas are not perfect, or they don't work out completely, or they have certain trade-offs that some people may like, some people may not like, it is permissionless innovation, right? So we can try all these things. And some of them might work out and some of them might not work out. And I think that's ultimately the beauty here, that we don't really need to ask anyone for permission. We can just see where it goes. Okay, so the dollar space chain. So you can have a consensus rule that says you need to know the price of, basically the relative price of a dollar to a Bitcoin. You can also use something else like the consumer price index or whatever you want, but let's keep with the dollar to keep it simple. And essentially what this means is that you have to somehow check the price of Bitcoin. And if you see a new block come in on the space chain and you disagree on the price that it says it has, well, then you actually reject that block. And so the idea is that, the price of Bitcoin is not really something we disagree on, generally speaking. And if you make it slow enough where you say, look, okay, well, look, we're not going to talk about the price right now, but we're going to talk about the price a week ago. And we get consensus on what the price was of Bitcoin to $1 a week ago. And you need to have a little bit of flexibility there, obviously. But if you do that, I think it's reasonable to say we can get to consensus in a way where even if your full node is running and for some reason you're connected to an oracle that tells you the price and they give you the wrong price, well, the chain just halts for you. And when the chain halts for you, then you have to sort of manually go and look and like, okay, well, what was the price? And since you can verify that yourself, or you can be reasonably certain that you actually will know what the price of Bitcoin was a week ago, you can get consensus. And so once we have that, once we have this oracle that is part of consensus, we can actually do the same burning mechanism, but now instead of creating one space coin when we burn one Bitcoin, we create 30,000 space dollars or whatever the price is. And so now you basically have a system that is, I guess you could say like a one-way pegged Luna, where you can turn your Bitcoins into dollars, but you can't really go back. And there's a couple of things that are interesting about this. So the first thing that's interesting is that dollars are made to lose value. So if you think about, like, let's say there's $1 million worth of these space dollars inside of the space chain. Well, 1 year from now, that $1 million is going to have less buying power, right? Less purchasing power. So it goes down in value over time already, like by default, because that's what dollars do. And so it's sort of similar to what I was discussing earlier about the burning mechanism, where you basically have a way where these where the value sort of exits the system, and that's sort of what dollars are designed to do. And for that reason, it might be reasonably stable. And so the interesting thing you come up with here is that you really have, given that the oracle is good enough, which I think is still sort of like a weak spot here, but it seems doable. You actually get this decentralized dollar. And then the second question is obviously, is demand for that dollar going to be stable? Or is the demand just going to taper off? And if the demand tapers off, then the peg doesn't hold, right? Because it's still a one-way peg, similar to space coins. So a couple of other ideas that I think are also interesting, but like less worked out. You could have a tokenless chain. You could do out-of-band fees where you don't even have space coins. And you just have a chain that really doesn't require any fees whatsoever. I think this is going to be somewhat centralizing, because you end up having to talk to a miner and pay a miner in order to add your transaction. And that party is probably going to be like, it's going to be inefficient to do that with multiple parties. It's going to be interactive as opposed to the regular fee-paying process, which is non-interactive, where you just create a transaction, you send it out into the P2P network, and you're good. So I think there are downsides and there are upsides. The upside is that basically fees are actually one of these things that are really frustrating in Bitcoin, where it actually creates a lot of problems with the Lightning Network, how to deal with fees, things like that. And if you sort of can take that out of the blockchain, that has a bunch of benefits as well. So it's good and bad, but again, like it's permissionless. Why not try it? Why not see what happens? Yeah, you can have a native stablecoin chain. I sort of talked about that already, the USDT example. you can have, that's interesting too, you can actually have awareness of Bitcoin's consensus inside of the space chain. And with that, you can do some interesting things. So one of the things you can do is you can have sort of a half-native atomic swap. I say half-native because basically the space chain knows what happens on the Bitcoin blockchain, but the Bitcoin blockchain doesn't really know what happens on the space chain. So you can have sort of a one-way, function where you say like, okay, well, if I create an output on the space chain and it says, you can claim this output if you send 1 Bitcoin to this Bitcoin address. And then as soon as somebody sends 1 Bitcoin to this Bitcoin address, they can claim the output on the space chain. And so this is sort of, more so than regular atomic swaps, which require these HTLCs. It's sort of half native. And another interesting thing as well is that you can look at Bitcoin's proof of work, and you can figure out basically how much hash rate, what the hash rate is that miners are creating in order to receive Bitcoins. So you can get this number from the Bitcoin just by looking at the Bitcoin blockchain, where you see, miners get, let's say, 10 Bitcoins, and they create this number of hashes in order to receive those Bitcoins. And with that number, you can actually create contracts that sort of speculate on the hash rate. And so you can sort of allow miners or whoever wants it to speculate on that value inside of a space chain. So this brings me to sort of where we're at today. So I'm working on this, and one of the things that I created is a Spacechains mining demo, which is available now on Signet. So you can actually play around with this. You can create these hashes and compete with other people via RBF and do this on Signet today. There's no actual blockchain yet, so that's going to be sort of the next step. But it's something you can play around with today, so if you're interested, please check it out. And I'll show you a couple of slides with some information about this. So first, I promised you some details about sort of what this mining, space chain mining looks like. And I said there's this one output that anyone can spend, but how do we get one output per Bitcoin block? How do we even get to that point, right? So what we do is we create a series of transactions. And I call this a covenant, but it's a pre-signed covenant. So it means that one person goes and signs an input and output with a relative lock time of 1 block, meaning every Bitcoin block, only one of these transactions can enter the Bitcoin blockchain. We're going to create a sequence of them. And so they have this covenant input and output, which just repeats every block. And then there's the secondary output, which is the anyone can spend output, the freely spendable output that people can compete over. So that's here, a 500 Satoshi output. So then people go and they can compete. So they create their own transaction, a user input, user output. They also try to spend the freely spendable output, and they add an op return with a hash. And this is CPFP, which means child pays for parents. So you're basically paying for the covenant transaction, and RBF is taking place where the secondary transaction, user input, user output, anyone can create that and people can outcompete each other via RBF. So eventually someone wins and it enters into a Bitcoin block, and then we get the person who won actually broadcasts their space chain block on the space chain network. And so, like I said, this is a covenant and it repeats every block. So it basically keeps going like this, where you get the exact same thing in the next block, and the covenant transaction just repeats. And it's good to point out here that the way that this works now is that the covenant input and covenant outputs, they are pre-signed. And basically, there is sort of a trust assumption there that whoever signed it isn't going to keep the key. So they have to throw away the key. But the nice thing is that it isn't that damaging if they were to keep the key. And we can do things like get a very big 1,000 out of 1,000 MUSIC2 multisig and make sure that as long as even one person of this 1,000 people throws away the key, the whole thing is safe. So we can make it pretty safe. But even if it wasn't, the worst thing that can happen is that somebody breaks the covenants and spends this in a way that is not supposed to be spent. And what happens then is that the space chain just halts. And it needs to be restarted with a hard fork. It's not ideal, but I think it's sort of acceptable today. And we can do better, but if we want to do better, we need a soft fork. We need specifically either opctv or we need SIG-hash any pref outs. And both of these are pretty high up in sort of the discussions today as to what people want in Bitcoin in the future. So there's a reasonable chance that we're going to get it, but even if we don't get it, we can move forward with this. So on the, in this case, SIGNet blockchain, what it looks like is here you have this transaction. So this is basically the top transaction you saw here first, right? Covenant in, covenant out, 500 Satoshi out. That is this transaction here. You get the covenant input, covenant output, and then you get the CPFP anchor transaction, which is the freely spendable output. In this case, there's 800 Satoshis in there, a little bit more, because it's a test, right? So I just made it a little higher. And this is sort of the second transaction where the sort of the users, right, user in, user out that I showed earlier, where someone puts in an input that basically pays for the fees with the change output. They also spend this freely spendable output, and they add their op return. And the op return, okay, no, wait, yeah. So, okay, this is the freely spendable output. So the freely spendable output has a redeem script, which is sort of interesting, where this is, for people who know Bitcoin script, and not everybody does, doesn't really matter that much, but for people who do, it's sort of interesting. So what this says is basically it puts a 0 on the stack, and then it puts, it says CSV, which is check sequence verify, which is basically a relative time lock. And so what these two codes mean is really, it means this transaction has a relative time lock of 0. And a relative time lock of 0 blocks, I should say. And a relative time lock of 0 blocks is not a time lock at all. It just means that after 0 blocks, this transaction can be spent. And the reason we do this here is because it actually incidentally enforces RBF. So RBF can actually be disabled on transactions, but by putting this into the script, you force the output that's spending it to have RBF enabled, because otherwise they literally cannot spend the output. And this sort of solves certain shenanigans, which can also be solved if we change how Bitcoin works in the P2P layer today. But without that, we can do it like this. So it makes sure that RBF cannot be disabled and people can keep outbidding each other. So then on the op return side, it's an op return just means basically it's a way to add data to the blockchain, and you sort of create an output that's not an output. The output is not spendable. And so what that means is that however many coins you put in this op return output, those coins are actually going to be burned. So that's sort of the mechanism to create these space coins. And because this is a test transaction, basically, really this is just some op return data, and it says one Spacechains test transaction. So that's the hash. Instead of a hash, I just put this text there just to show that it worked. So if you want to check out this demo, you can check it out on my GitHub, Ruben Somsen /Spacechains. There is a Telegram chat room at t.me/Spacechains. And yeah, that's it. Thank you very much.